Hello and welcome to this fourth video in our lecture on user authentication with passwords and biometrics. So in this video, we want to answer a question we asked earlier about how to protect a system against an offline dictionary attack on passwords. And the standard technique that's used these days and has been used for quite a while is called salting. So the idea here is to add a salt to the password before it is hashed. So basically, the user is going to pick a password. The system is going to randomly assign a sequence of bits called a salt or salt value. This is going to be a bit string of a fixed length. That's the same length for all the users, but every user gets a different one because the salt is chosen randomly. And so the salt is going to be concatenated with the user provided password, and that result is hashed, not just the password. So in such a system, then, what would need to be stored in the password file, in a system file? Well, obviously, you would have a record for every user. Then for every user, you would have to remember their username or user ID. And then, of course, you would have to remember the salt for that user because this is a randomly assigned bit string. And so it is computed once and then remembered and associated with the user. And then, of course, the system file would not contain the password itself, but it would actually contain the hash code that is obtained after the salting. So I want you to pause the video and read this description, the general description of how such a system would work. And I also want to think about why salting passwords would be a good idea. How would that actually limit the scope of possible attacks and in particular protect the system against an offline dictionary attack? In the next slide, when you get back, we'll discuss this mechanism in more detail. Okay, so it's a two-step process. Here we're going to talk about the step that takes place when the user is first creating their password or when they're resetting their password to a new value. So this password here then is given by the user, is input to the system by the user. At that time, the system is going to randomly generate the salt value. Okay, this is a random bit string of a fixed length. So what's going to happen is those two values are going to be concatenated with the salt followed by the password or vice versa. In terms of order, it doesn't matter for us. This resulting concatenated string is going to run through a hash function, and the output will be a hash code that will then be stored into the system password file. And remember, the password file is going to contain an entry for that user, including their user ID, the particular salt that was just generated for that user, and then the hash code that comes out of this stage. So this is step number one, where the password is first salted, then hashed, and then stored into the system password file for later checking. Before we discuss the other side, which is the verification of the password on later attempts at login, let's talk about the name salting. Actually, there's a lot of controversy about where that name comes from. There are several theories. I encourage you to look that up for some fun reading. But in this case, the way I like to think about it is that the reason it's called salt is because you're adding it to your main dish, say, to make it taste better or to be safer. And just remember that the salt, usually you just add a pinch, despite this picture here. So a pinch is what? It's just a little bit, right? So the salt shouldn't be that long. It should just be a few bits. And also, when you pick some salt, particularly you grab a pinch, you're usually getting some random grains of salt. You're not picking the salt particularly. So this is really a random fixed size sequence of bits or grains of salt. Anyway, that's the way I like to think about it, but that is not the original etymology, which I don't actually know because nobody agrees anyway. Never mind. Let's say that we have this password file that contains an entry for each user, and the entry has the three components that I just described. So in a second step then, every time the user is going to try to authenticate him or herself, we're going to do the user authentication step. Remember, that's the second step in the access control process that we discussed in the first video of this lecture. So let's say a user comes in or tries to log into the system. They're going to type in their user ID. That's the identification step, right? Then they're going to provide their password. And at that point, what's going to happen? The system is going to look up the user based on their user ID in the password system file. Is going to find the entry for the user, recover the salt, grab the salt, concatenate it to the password in the same order that this was done in step 1. So in this case, the salt and then the password is going to hash the resulting string and then compare the result with whatever hashed salted password was stored in the system file. If there is a match, then the user is authenticated. Otherwise, they have to try again. So make sure you're comfortable with the process of salting the passwords of the user. And as a final question, I want you to think about why in both pictures here, it said that the hash function that we were going to use is actually a slow hash function. So remember that we said hashing is a faster operation than encryption typically. And in this particular case, it might actually be too fast. So we want to artificially slow it down. So we might want to pick a slow hash function. I want you to think about this after you end this video, and we'll talk about the next topic in the following video.